Thank you, everyone, again, as Mia said, for coming today. You want to present yourself first?
You go.
Okay. So my name is Moutia. I'm the Tech Accelerator Tech Lead. Basically, my job is to make sure that we are building efficient, state-of-the-art application based on AI capabilities. So I follow up on the design of the architecture, the implementation of our model training, inference, infrastructure as code, all the DevOps topics and stuff like that, but and also the web development that Mia take care of. And we're going to be doing this talk with my partner in crime, Olesia.
Hi, my name is Olesia. I'm a data scientist on the team, and I try to keep up with all the requirements that Moutia puts in making things clean and automated. And yeah, I'll give you an example later on about how we do things over here.
Okay, so let's get started. So as Mia said at the beginning, what we're going to try to explain here, we're not trying to recommend anything, to sell anything. We're just showing what we do, what are our convictions. Just happens that we are a team that is 100% full GCP when it comes to architecture and infrastructure. So what we're going to describe here, it's the same principle can apply to any other cloud provider. Technology is a little bit different, sometimes more mature on another cloud provider than here or the opposite. So yeah, the takeaways, we're going to talk about them at the end. But yeah, it's not exclusively to do on GCP. So I'm going to start by explaining what kind of MLOps framework we built at the Tech Accelerator. And by the way, it's something that we're trying to make global at L'Oréal. So we worked with RNI, with Modiface also, to make this a global standard that will apply to every ML project soon at L'Oréal. Then I'll give you a glimpse of a big glimpse actually of the technical architecture on GCP. So how did we build our GCP stack to train, to do batch predictions, live predictions, and deploy our models in an industrialized way. And then Olesia will give you a big picture of how did we implement this on Vertex AI for a use case called consumer loops. She will explain what it is exactly. And then we'll end up with the learnings and takeaways. So what is our MLOps framework? In this slide, I just put like 4 problems, classic problems, I think, that every or most of the ML engineers run into in their daily lives. For me, the first one is the lack of visibility on models usage and standardization, because we don't know actually who's using what and how. Just by raising your hand, if you go through these 4, who knows these kind of problems, who encounter these kind of problems in your daily lives? Yeah, so most of us actually. So yeah, second one was taking the model to production. It's kind of messy. We don't always know which kind of experimentation we're going to take to a further environment. Tracking is painful. Being blind, what I call being blind on model performance, there is a spelling mistake, by the way, is that when I arrived at L'Oréal like almost 2 years ago, we had no ways of measuring how a model was performing. We didn't do retraining that much. So yeah, we couldn't see if there is any drift actually happening with our models or with our data sets. And the last one is not being able to experiment, iterate more often. So our organization is called Tech Accelerator. So you can guess that we want to go really fast. Sometimes we need to deliver a product in 6-8 months, which is pretty fast. So we don't have the luxury to take a week or a month to deploy a model to production. We need to, if we have an idea today, we need to be able to experiment it and like test it, iterate 10, 20 times, and then deploy by the end of the week. That was something that we didn't have a year and a half ago. Thanks. Take all of it. So what is MLOps and why do we need it? So I already explained all the painful topics. This is where MLOps comes in. So the literal explanation is that it's a methodology that will allow ML engineers to unify all the ML development, but also the ops operations to make sure that we are deploying the right model in the right environment quickly and in a standardized and industrialized way. So it's a set of tools, but also a set of methodologies and also a mindset shift. This is something very important because the tooling is not the only thing that we need to focus on when we're building this. So what will MLOps provide us when, let's suppose that we did set up everything and it's working, it's running, all our products are compliant with our MLOps framework. So it will be shorter development cycles. It means that we will iterate faster and we will deliver faster, we will reduce our time to market. Better collaboration between teams because our data scientists are working with our DevOps and they don't need an ops guy to deploy a model. It will happen automatically. Increase reliability because we know that we can reproduce a model in an environment. We can reproduce an experiment. We can track performance and monitor the models. Governance processes because we know that we can version these models and come back, roll back to another version based on a new data set, on an old data set, because we can track every one and each of them and decide which one is more adapted for our use case. And the increased ROI is just mainly that we invest a lot at the beginning, but then everything will roll. Not at 100% alone. We need to maintain that, but still it will allow us to really reduce our project cycles and iterate fast, innovate fast. So this is what our process looks like. It might seem a bit theoretical here, but this is the standard that we agreed on at L'Oréal. With 6 steps. First, experimentation development, then training and inference operationalization, continuous training, model versioning and deployment, then prediction serving and continuous monitoring. Few of these steps need to access the data sets that you're training your model on, and also need to access your model registry. That's what we call model management. And actually, at the end of this process, what we call the continuous monitoring is all the action that will allow us to detect drift or if we have any breaking change. And then it will trigger a new training of our model or a new experiment because we have a new feature to add. And so it's something that it will go in the loop. It doesn't have a start at the beginning. It's something, it's a cycle actually. So once we set this, how would we implement this kind of process? Something important to know is that for all our projects at the Tech Accelerator, we have a GCP project architecture that is standardized for all of our products. So we have one project per environment. It happens that we have 3 environments here, development, staging, and production, but we can create as much as we can because we are using Terraform 100% of our products, so we can just pop as much environment as we want when we want and destroy them when we want. But minimum set is to have these 3 and have a transversal environment that we call DevOps or DataOps because it does both. So this environment has all of our CI/CD chains. So we use Cloud Build. So we have all the Cloud Build pipelines to do CI and CD and deploy in the 3 other environments. But we also have all the DataOps environments. So all the data, external data or internal data coming from other projects or from external providers is ingested into this project, version into this project. So it will form what we call a consumption data set. That will feed all the model trainings in the other project. Sometimes it happened that all the trainings for our models are also handled in a transversal way in this project, and then they are deployed in the other environments for inference. So that was the logical view, and this is the technical one. Just so you know the basic services that we use, GCP. So Cloud Build, as I said, GCS for storing data files, all the artifact registry also for the Docker images and Python libraries, for example. And for the environments, we have Vertex AI for the pipelines, BigQuery web applications, because all of our products are based on a web application that is consuming the models behind. So who knows Vertex AI, by the way? By raising your hand. Okay. So Vertex AI is basically the ML and AI platform at GCP. It's been branded like Vertex AI for like 2 years now. So I won't say that it's the most mature solution on the market, but it's evolving pretty fast. They already have a lot of capabilities, but almost 20% or 30% of what you see here is still on preview. But it doesn't keep us from using them already. You have a lot of features actually, but we only use this. Continuous monitoring, we just started using it. Predictions and training. For data labeling, I did put this logo. I don't know if anybody knows it, but it's Label Studio. So we choose to use an external tool for labeling data that we implemented on GCP. It's an open source one. Pipelines for orchestrations and trainings, and also notebooks. We use a lot Workbench for experimentations. So we, on purpose, choose to not talk about all what we use in Vertex AI today because it's going to take a lot of time. I'm going to mostly focus on predictions, training, pipelines, and that's all. So just to give you an idea about how do we deploy everything actually for our products, this is a logical view of what our DevOps chain looks like. So we use mainly Cloud Build with the triggers that are built on GitHub. So we do all of our integration tests on the Cloud Build pipelines, the unitary tests, and then we do some code auditing with the SonarQube. So this slide is not up to date, but then to be defined for functional testing is already being implemented by Mia. So we use a tool called Test Team, but that's mainly for the functional testing on web applications. But all the rest is also available also for models. We use, as I said, Terraform to deploy infrastructure, and we apply the same principle of CI/CD to infrastructure as code as to software, actually. So even for doing Terraform applies and Terraform plans, we use Cloud Build pipelines. Something very important also here that make all of our projects really accelerated now is that we worked a lot a year ago on building templates for every component that we use. Actually, we have the chance that all of our applications have a standardized architecture almost, because we have a data layer, we have a web application, we have the modeling, and we have the infrastructure. So what we did is that we built all the Terraform modules that we need, the Python modules that we need, and the JavaScript also modules that we need. We're still doing some progress on that. And for every repo here, you have a GitHub repo template. So when you start a new project, you clone that template actually to start your repo. You don't start from scratch. What is cool about that is that it comes already with everything you need. It comes with the pipeline, CI/CD pipeline already configured. It comes with the infrastructure as code already configured. For the data and AI repo, it's more than that. It comes already with CI/CD, with the Vertex AI pipelines already scripted. You have all what you need actually to create your components and your pipelines. You have the integration tests that are already configured, and also the deployment that you're gonna how you're gonna package your pipeline, deploy it on Vertex, and then trigger it. So actually, to start a new project on Vertex, it takes less than a day today instead of a few weeks before. So yeah, just this is what is most interesting for us today is this kind of templates that we made. So data and AI repos. As I said, you have the structure for your pipelines, the components, the source codes where you can have the choice between building a pipeline with you using Python libraries or Docker components. So you get to pick and choose into that structure that you already have and delete what you don't need, and it will make you gain a lot of time. So this is what I've been already explaining. And this is the most fun part actually about it. This schema must look a bit impressive, but actually it's pretty simple. And I'm gonna walk you through it. I like this effect. Oh no, it didn't work that well. Okay. No, it doesn't. It does here, but not on the screen. Okay, so this is the training architecture that we implemented. And as I said, we have the template for the data and AI repo, but it comes also with the template of infrastructure. So all of this is already templated. So unless you need something very specific, you don't need to create anything new here. All of this already exists. You just need to change the variables, actually. So we have the cloud build triggers. Whenever you're pushing something to your repo, it will build and package a new pipeline artifact that will be deployed on Vertex AI, and it will run actually the training either manually or automatically or with a schedule. It will use some input and output data from BigQuery, and then it will deploy the model once it's trained to Google Cloud Storage and also to the model registry. Now that we have our model that is trained, we have two ways of doing predictions. Either we're building a pipeline first, and it's an inference pipeline. What we need for that is to package our pipeline artifact. So everything is already packaged in the code. You're just going to go and set your components. So you basically are going to work only on the components instead of working on the whole code. We also offered in that template a possibility to have pre-built libraries, Python libraries that you can include in your pipeline also. So your inference pipeline to do batch prediction is going to be using maybe a model artifact that you already trained, or a pipeline artifact that you already packaged here, or and also libraries, Python libraries that were already packaged before. So once you do that, you have your pipeline artifact already packaged and deployed. So then it will give you the possibility to run your inference pipeline on Vertex. What we did for that, because today, if you know a little bit the limitation of Vertex, when you package a pipeline, you can't run it unless you use the SDK, the Vertex SDK. There is no way of running it manually or with a trigger. So what we did is that we deployed, it comes also with a template. We deployed the cloud function actually that used the Python SDK inside to trigger that pipeline. So we can trigger that function either manually or with the scheduler or something else. So whenever we trigger that function, it will run the inference pipeline to do batch predictions. So that's the first option. Second option is that we use the model artifact that we trained to be deployed either in model endpoints on Vertex or on Cloud Run. To be honest with you, we mostly use Cloud Run today because we have a scalability problem with the Vertex endpoints because it doesn't scale to zero. Once you deploy an endpoint, you're going to pay for it all the time, either you use it or not, which is not the case for Cloud Run, even if you have this cold start effect at the beginning. But yeah, it's something that they're working on, but it's still not live for now. So we mostly use Cloud Run to deploy in our models today. But yeah, I think that in next year, Vertex endpoints might be something better usable and being able to scale to zero. So once we did this, we have these two possibilities. We have our web application that is already deployed. And this web application is either going to consume the data that is the output data from the batch predictions, or it's going to call the API, the model API directly to do live predictions. So yeah, that's it. That was the big glimpse about our global MLOps architecture. I think we can, should we take questions now or maybe later at the end? Later at the end. Okay. So now I'll let Olesia explain to you how did we do something similar, but with a real concrete use case called consumer loop.
Thank you. So yes, I'm going to talk to you about first what consumer loop is, just to give a little bit of context, and then how we used Vertex AI specifically. Try to go quite fast. So for the background, consumer loop is a tool that we've built to analyze ratings and reviews about the products, laureate and competition. So it takes a lot of ratings and review from different online providers and retailers and does topic and sentiment analysis pretty much. So one of their key part of their tools is sentiment analyzer. We want to be able to say for a specific product like the one you just saw, what are the positive and what are the negative topics. So there is a sentiment, there is a model that's trained behind, and want to make sure that it's automated, that it's trained, that's updated regularly. So that's why we wanted to have a Vertex automated pipeline for that. Just what is behind, we have a quote, we have a bird that's pre-trained, and then we fine-tune it with some examples, and then the output we predict is a rating, and like a 5-star rating, and we use it as a proxy for the sentiment. So 5-star and 4-star, we assume that's positive, 3-star is neutral, and negative is 2 1-stars. So based on the output of the models that does probabilities around this star ratings, you'll be able to say what sentiment it falls into. So fine-tuning BERT model, you do need to have something in place to make it easy. Yeah, just an overview. You load the data, we preprocess the data, train the model, evaluate the model, save if it's good, pretty standard approach, but how do we make it more hands-off than we would before? So in Vertex, it looks like this, which looks kind of long and complicated with a lot of parts, but they're actually repetitive parts that are quite easy. They're components that make it up. So really, it's just a flow of steps that come one after the other, and they're components as these individual blocks that run independently within each other, independently of each other. And just to make one component in Vertex AI, it's quite simple. The function is the same function you would use in normal code. You just add this component part to their top, saying what kind of packages you need, what image you'll be using for this specific component, and what is output file. That's more for Vertex AI. So really, you need to specify what you need in there for it to run, and that's it. You add it, and you're good to go with your components. And another cool thing that you get throughout the process is that you get the artifacts that you can then go back to. So once the model is trained, you can get the model artifact, or you can have their evaluation metrics that you can go back to. You can get the data sets that you had used. So everything that came into it, it's a part of the process, and you can refer back to them. And again, code-wise, pretty simple. You'll specify that that was an output, and you just add this train data set to path. This is kind of the part that makes it a saved artifact, like that block on the flow. So again, very minimal effort to get their automated flow. So to go closer into what it works, how it works, you'll see pretty standard steps that should be familiar. You load the data, then it gets saved as this artifact of the data set. You split it into train data, so you get train and validation. You preprocess it, you save this model that was used for preprocessing, and you have your data set that will go into training. So just a visualization of some things you'll probably use. Once you've got your trained model, you can again save the model, bring back the taste data set that you have split in the beginning, and do the inference. Once you get your prediction, you do the evaluation, you save your metrics, and you can save the model if it checks off, like the performance was good enough. There are other things that you can add throughout the process that make it even more visual and easy to manage. You can have visualizations of the training process. So you can add a TensorBoard and show the logs of the model's training as it happens. yeah, for their inference, this is also the same block that you can use later on. So it's kind of the same architecture. Evaluation metrics, they in the platform, they will kind of display there on the side, so you can just click and you see everything again. You don't need to make any extra effort once you set it up. And it's conditional saving, so once it's retrained, you don't need to think about anything. It will be saved if it's good enough. So yeah, that's me. I went very fast, not to take more time. And then for their learning, some of the things to why we like using it. It's first, it's serverless. You don't really need to set up infrastructure once you have all these blocks. And what Moutia was talking about, we have the template. So really, me, when I'm building my pipelines, I can take everything that's already there, just fill in the gaps to tell me what it needs to be there. But everything else then runs. I care about what's data science parts of it. Yes, it's flexible runtime. It's vertical scaling. You can set up some of the limits to like to GPU, for example, or memory limits, but otherwise it will make its own decisions based on what it needs. It's reproducible. You saw in that pipeline, you see the blocks, so you can get back to the same data sets. You know everything, you can reuse it again and again. And yeah, I like that it's automated saving. Again, I don't have to go back and check anything. It will be there if it's good. A word of caution on Vertex and the way it works right now. The components, the steps within themselves, they are self-contained. So anything you need in there needs to be defined within this train model function. You'll say what packages you need to use. And then if you want to specify a different function that will be used, it will be kind of nested definitions. It can explode in terms of complexity. It's also really hard to do unit tests in this way. So what we do is our solution that we propose is taking all of those internal parts outside, packaging them, and then you can import them in here. So for example, when you import packages, there are some that are standard, like, well, actually, none of these are standard, but you can like import pandas that would go from normal pip install, but you can also specify a part on the GCP where all of your specific packages are. Like I created, well, not me, the team has created the sentiment analyzer and it's saved here. So when their component is created, it'll know to look for that as well. And the sentiment analyzer itself, I can test it separately outside of this pipeline. So this is really mostly for orchestrating all the steps, but to make sure they do all the unit tests, you can do it separately, then package them and put them in here. And then, yeah, all of it will just look like this. Like this would be all the steps. And my trainer is my sentiment trainer. That's everything that needs to be sentiment analysis. If you go into sentiment analysis, that's layers and layers of functions inside. And we won't go into this, but we like to use Poetry here for packaging. We think it's a very user-friendly. It saves everything that you need and import as U-code. So any libraries that you go, what? Yes, it manages dependencies very well. So that's what we use to package our separate code and then put it into the pipelines. So yeah, and then a couple more things, learnings.
So yeah, now I imagine that everybody's super excited about implementing MLOps starting from tomorrow. But yeah, I thought that these three topics were really important to keep in mind because it might seem very sexy like this, but I think that we need to keep in mind that automation is key. We need to put this at the next level and try to not lose time on tasks that will be repeating themselves all the time. So we automate whatever we can automate. A platform is not enough. I was discussing this with Olesia this afternoon, and for me, having your technical setup being there is not enough because we need to have a mindset change and mindset switch and collaboration between the teams to succeed in these kind of missions. Because you can have all the technical assets you want. If you don't change your ways of working and your collaboration and your mindset, it will not work. Think big, act small, meaning that you should have like the big picture of your strategy where you want to go, but don't try to do everything at the same time. Start really small. Start by industrializing your training pipelines, for example. Start by using one feature of Vertex AI or any other platform. Train on it, scale up on it, and then try to scale. We don't try to do everything at the same time. So yeah, that's all. I think that if we have all of this being set up, this journey can be a real success.